All right, let's see if we can get started. If you'll take your seats, please. So I'm John Montgomery, and this is Michael Edwards. And before we actually get started, maybe it's the fact that I'm running on 2 hours of sleep, but on the airplane on the way in this morning, these two kids came on. They were about 7 years old, I think brother and sister, and they spent the entire plane flight telling each other jokes. So if you want to hear the state of the art in 7-year-old humor, I have a joke that it's just been cracking me up all morning. Michael, what did the 0 say to the 8?
What did the 0 say to the 8?
Nice belt. I liked it. I don't know why. Anyway. And it's short enough that I can remember it. So we're going to tell you a little bit about web services and SOAP, the Simple Object Access Protocol, where we're going with this stuff, why it's important to Microsoft. Michael's going to show you a demonstration of the Web Services SDK, which we've promised to deliver at the end of this month. So you're actually the first people to be seeing a demonstration of this. And after the demonstration, I'm going to go kind of high level on you and tell you about some of the business models that are around this stuff. Probably less interesting to a developer audience, but it's questions we get a lot about kind of like, how are you going to make money off of this stuff? You've probably seen this slide a few too many times. I'm not going to dwell on it, except to say that web services and WinDNA 2000 are integral to each other. The concept of web services, which is basically using software that lives on the web as a service, like an ActiveX control, is something that WinDNA is going to be supporting innately. It's something that's we're going to make it very easy to expose software as services and to consume these services into your applications. Most of you guys are probably building applications today, and you're familiar with the paradigm of I program against my local user interface, my local data store, my local file system. I'm using all sorts of services that reside on my system, or they're remoted transparently through something like DCOM to another system. But it appears to you that it's local when it works. Well, a few years ago, you may have noticed this thing called the internet kind of happened. I think we noticed it maybe last month or something. And what's interesting is that it's actually an extension of this same model of programming against local services and then projecting that user interface to a browser, which turns out to be a very rich way of receiving, especially forms-based information. Now, one of the reasons that the web really took off, and one of the reasons that we find it so interesting, is that the declarative programming model represented by HTML makes developers incredibly productive for some of the more mundane things like drawing text boxes and submit buttons and pushing text out to people, basically forms-based interaction. It's very easy. There's a very low barrier to entry. One of the keys for web services going forward is to leverage this low barrier to entry, this productivity that the internet represents, and to bring it back into the application, the app code itself. If you actually look at any portal today, these portals are actually made up of tons of web services. There's mail, a calendar, financial information, news. You can read the stuff on the screen as easily as I can. Now, what's interesting here is that a Yahoo or an MSN would have to build a lot of this infrastructure itself. They have to build their own email backend, their own calendaring service. They have to figure out how to grab financial information from some provider and surface it. Same with news information. Most of them don't actually, have their own weather stations around the country, so they leverage the meteorological survey data or another service like weather.com. Now, what's interesting about this is that for all of those services that you see, there are a ton of services that are going on behind there that you never see. There's logging in, remembering your preferences from session to session, logging advertisements, keeping the user state persistent across sessions, doing things like eBay will let you monitor auctions and stuff like that. All that stuff is things that a portal, in this case, I'm just using it as an example, has to build itself. There's not a whole lot of opportunities for code reuse. What's happening, though, is that these guys who are trying to integrate these services together are finding that they're actually going out to other services and, for example, screen scraping the HTML off of them. That's how they get their news headlines, for example, off of ZDNet. Or, like with the financial information, the architect at an MSN or a Yahoo is going to pick up the phone and they're going to call a Schwab or a Morgan Stanley or somebody who has access to that kind of information. And they're going to create all sorts of service level agreements about what quotes get delivered in what time frame. Here are the protocols for doing it. Here are the APIs for programming against our back end. When you want to do something like that, with the HTML screen scraping way, you can usually get it up pretty quickly. It's very brittle, though. So when the portal is trying to do something, if the service it's relying on changes the HTML in any way, their news headlines are going to break. Similarly, the challenge with the example I brought up of integrating stocks is that when you want to do something like that, you wind up spending 3 to 6 months having your top architects talk to each other about how to create this business-to-business relationship. Now, what web services is about is making that business-to-business relationship simple. It's about exposing these services in such a way that they're basically COM components or not COM components. Because the cool thing about these services is you never know what's on the back end. You don't know what operating system they're running. You don't know if they support an object model at all or what object model they support. You don't know what programming language these services have built their infrastructure in. Yet you, the developer, still want to be able to consume them just in the same way you would consume any other type of component. In order to make this stuff work, there are a few key things that you have to get away from and kind of get above. The first one is that the model of communication between the application that's consuming the service and the service itself is a loosely coupled asynchronous model. It is not a model like the one DCOM uses today, or Corba, or Java RMI, where when your client comes up and it makes its call to the service, that service stays up until the client is done with it. It's the web-based model, where your client makes the call, the service fires up, returns the results, and dies. It makes the system much more scalable and much more reliable, because you're not having to deal with long-lived connections that can have memory leaks and stuff like that. The other thing that's really important is standards. In order to make this work, you have to not invent any new technology. The key that we see to getting this done is through XML. XML enables us to richly describe any data source and to enable us to operate on that data source as though it were a relational data set or an object or even a stream of messages. It makes programming against that back end very flexible. It also means that because this is XML, W3C standard, right, you don't have to worry about somebody coming along and changing it arbitrarily. You don't have to worry about it being rigged by one vendor. It's standard XML. It's going to operate on all these different platforms. It's something the industry has really bought into. Some of the key pieces of infrastructure that Microsoft is going to be providing, and we imagine a bunch of other people are going to be providing, are what we've called mega services so far. They are things like passport authentication. There are over 200, I think there may even be over 300 now subscribers to the passport service. It's the 10th most visited site on the web. but nobody types in www.passport.com. What's happening is that when you authenticate at a barnesandnoble.com or a buy.com or a Hotmail or something like that, your credentials are being passed back to Passport. It's being authenticated, and Passport is saying, yes, this person is who they say they are. Now, not only does that mean that the people who are trying to have authentication in their website, in this case, don't have to write all that authentication code. They can leverage Passport as a big component. The user experience improves dramatically. I don't know about you guys, but I have a fairly common name, John Montgomery. And when I want to get accounts with my trader, my stock trader on Yahoo, on Excite, on Hotmail, I have to remember all these different accounts because, you know, J. Montgomery, John Mont, John_Montgomery, they're often taken. Now, what Passport enables the user experience to become is I remember one username, one password. I can authenticate against all these sites. Similarly, there are a lot of folks who are talking about this concept of a great big disk drive in the sky, where you can share files with people. You can treat it basically as a local file system. The question is, how do you get to that? How do you integrate with it? Right now, things like that are like HP Cartoga. They're used mainly for posting photographs to share with other people, that kind of stuff. But the thing is that that's a full-fledged file system up there. And it's backed up by somebody else. It's accessible from any of a number of different types of clients. Whether you actually have your computer with you or not, you don't have to PPTP in anywhere to get access to it. It's just up there. What this enables you to do is to treat it as though it were the local file system service, program against it, it's remote, program against it as though it were local, it's remote, it lives up in the web somewhere. It's kind of pretty cool. I'm not going to talk much about these other things, except you can imagine a future very easily where technologies like Application Center 2000 are actually building block services. And when you want that kind of functionality, rather than actually buying Application Center 2000, you can lease the service. And the service will be managed by someone else. And when you want to install a new system, there are calls that are made back, and the new system comes up online without you having to actually buy and install some software. The key to making all this work is separation of that implementation from the protocol. So if you look at something like Hotmail, which is an example of a web service that can be integrated in fairly easily for mail services. As many of you probably know, Hotmail does not run on Windows NT or Windows 2000. It runs on some Unix variant, I think FreeBSD. In order to make that work smoothly in our Windows environment, we had to make sure that there was an abstraction between the APIs that they called and the ones that we were calling. And that abstraction is to put XML on the wire. Now, what's interesting here is that there are actually 3 layers of XML that you need to agree on in order to get this kind of seamless world that you can get with today's COM components, where you can just install them and access them very easily. At the lowest level, you have to agree on a common message format. Now, we've been talking a lot about SOAP for about the last 5 months since we released it, gave it to the IETF as an internet draft. We've revved it to version 1 in December. There's a lot of active development going on within Microsoft around SOAP. Basically, the fundamental tenet of SOAP is I can serialize anything, stick it on the wire as XML, and the other end can deserialize it. That's actually kind of simple. There's not a lot to that. Technologies like BizTalk build on top of that, for example, they add routing capabilities to it so that you can get much more interesting layers of what can be done to messages when they are received at the back end. More importantly, above that, as most of you guys know, you need something like a type-lib, an IDLE, something that actually describes the capabilities of that service so that when you consume it, wow, there are actually people out there. Oh, damn. So you can actually consume it. You need something that tells you what the marshalling should be. this is a description format, basically. And description formats come in many forms, from the very simple, which is basically a web IDL type thing, to very complex, in which you are actually choreographing the interactions of many different services. So at the very simple level, you know this. You need to be able to describe the concept of an interface, of methods, of parameters. Otherwise, when you're talking to this service, you have no idea what it looks like. You have no way to instantiate it as an object that you can actually program against. So Microsoft is working on some stuff there. This is basically, the concept is a service description or a contract description. Further than that, there's some stuff we'll be talking about in the coming months about how to take multiple different services and make sure that when you integrate them together, they're activated in the right order. I mean, one of the problems we have with programming now against simple type lives is that, how do you know that all the parameters are set right before you actually invoke the method? How do you know what variables are hanging around? Well, there are actually ways that you can describe that using XML. Above that, there's actually the concept of how do I find these things? And like message formats and like description, there's the simplest thing, and then there's kind of how it grows out to the side. So the simplest form of discovery is when I go against a web service, how do I know where to find that service description file that's going to tell me how I can communicate with the service? But beyond that, there's actually the concept of how do I create some kind of a Yahoo of web services so that either when I'm in Visual Studio and I want a component that does authentication, I can easily search and find, here are the 10 different components that do authentication, then find their service description. And the concept that you need to be able to browse to these things just the same way you can do with like componentsource.com. You can go and download COM components. So we need both those layers of discovery actually to become available. And as you've guessed, Microsoft has some thinking there. For those of you who have been following the should SOAP be standardized, how should SOAP be standardized, how many of you are familiar with SOAP, by the way? Just cool. How many of you have subscribed to the Developmentor SOAP discussion alias? Okay, a lot fewer. That's something you actually might want to look into if you're interested in SOAP. That's www.develop.com/SOAP. Don Box is one of the co-authors of the SOAP spec. Anyway, so there's been a lot of discussion recently about XML messaging, SOAP, XML RPC, the IETF, the W3C, EBXML, OASIS, stuff like that. Microsoft is committed to standardizing all of the stuff necessary, the basic stuff necessary to make it easy to expose and consume services the way I've just described. Now, whether that's actually going to emerge at the other end of the standards process the way it is today, I don't know. But it's kind of like Jonas Salk, the guy who invented the polio vaccine, said, you don't patent air. I mean, some of this stuff is so fundamental to this new model of building applications that it's not something where Microsoft is going to make a huge vested stake in, buckling down and saying, no, you can't go there. Instead, we're going to be competing with implementations, with services, with tools that go around this. I get the question a lot about, how is Microsoft going to make its money if it gives the protocols away? And the answer is, the protocols are free. The interesting stuff happens above the protocols. And some of that interesting stuff is actually going to be coming up in the Web Services SDK. So for those of you who aren't familiar with SOAP, it is basically a way of serializing XML into an HTTP packet and sticking it on the wire. The keys to it are that it's extremely simple. You can actually implement a SOAP listener or a SOAP client in a few days in pretty much any programming language. The Python guys have done some pretty amazing things here, actually, with dynamic registration of components and stuff. It enables you to actually perform cross-object model conversions The cool thing is once you have XML on the wire, you can represent it however you want at the other end. So like RogueWave has this product called Zorba that is actually a SOAP to Corba bridge. So their SOAP components, their Corba components can talk SOAP, and we can pick up that SOAP from COM. So we can talk seamlessly to a Corba component through SOAP. And part of the way we did this is that there is a common type system that's represented in SOAP. That's actually one of the toughest problems, is getting the type system to work. There are still some challenges that have to do with like lifetime management and some of the higher level services that are in COM and are in Corba. But it's just a matter of time before that stuff is utterly smooth. And this is at the bottom of the page is the URL for where you can pick up the latest version of the SOAP specification. We're actually, since this is under non-disclosure, we're actually going to be updating that to SOAP version 1.1 relatively soon, the next few weeks. Basically, it's bug fixes, errata, and typos. It's not a major change. A little bit more inside what a SOAP packet looks like. It's basically a standard HTTP packet with two parts. We have added some headers, one header specifically, to the HTTP headers that identifies the method name that's being passed through. This enables, in theory, a firewall to filter on that and say, I want to allow it or disallow it. Part of the goal with SOAP is to make it very firewall friendly. One of the challenges, as you know, with DCOM or IOP or Java RMI is that getting it through a standard firewall requires a call to the administrator to open up a port. With SOAP, it runs over port 80 because it's encapsulated in HTTP. But we do want to give hints to firewall makers and people who want to be able to filter on that. It comes through as type text XML, and that SOAP method name header enables theoretically the firewall to actually filter upon what is trying to be done. Now within the actual HTTP packet, the SOAP envelope has two parts. There are the SOAP headers, and those are where you put things like the BizTalk routing tags. That's where you might put transactional information or queuing information or context information. It's fully extensible. We basically just say, here's how you define a header. Put whatever you want into it. In the SOAP body is the actual method call and the data serialized in XML. One of the questions I get most often is, okay, great, you've just opened a huge security hole. That was really brilliant of you. And the answer is, well, yes and no. I would actually argue that the most dangerous thing that exists on the web today is HTTP GET. That is what enables you to download executable files, zip files, Word documents, other things that can contain viruses. SOAP actually doesn't pass code around. Web services don't require moving code from the service to the consumer of the service. Instead, what they're passing is a description, for example, serialized data or the service description itself. So that when your tool, for example, when you're building against that service, when your tool instantiates the proxy to program against, it's your own proxy. Further, the developer who's exposing the SOAP service knows full well what they are exposing. You have to explicitly say, I am exposing these methods, these interfaces, these parameters. It's also type safe. So we enforce type safety. There's no way you can do arbitrary castings of one type into another. SOAP is strongly saved. And on top of that, of course, it works with HTTP. It works with HTTPS, which means you can use X509 certificates on either end to verify both the client and the server that they have the rights to actually access this service. You can encrypt the connection between the two of them using HTTPS. We're actually looking at how to have much finer-grained control over what actually gets encrypted inside the packet, because as you actually look at it, you can picture a SOAP envelope that has a body that's broken into multiple parts. And for example, you could have the admin, the employee, and the manager. And different parts of that packet need to be viewed by different people. Now, what we would actually want to be able to do there is to do something like a triple DES encoding of each of the three different parts, so that the manager can see all of it, the employee can see a subset, and the admin can see even less. And we would basically use a certificate to guarantee that the correct packet was being decrypted correctly for the right person. There are a bunch of issues also around non-repudiation that requires authentication. Authentication is really key to this, and the Passport guys have actually worked out some pretty slick stuff for enabling very rich authentication, which isn't exposed yet. But so far, all we've been talking about is just getting XML on the wire. And intrinsically, XML is not something that's particularly easy to program against. The DOM, for those of you who have experience programming the DOM, it's not exactly a high-performance way of building applications. What it actually turns out you need to be able to do is to have some kind of an engine that will make it easy on the server to expose a service and on the client to consume it. In the case of the Web Services SDK, which will be shipping broadly at the end of this month, I hope, what we're enabling you to do is it's Windows-centric. Now, that doesn't mean you can't use it with other services that are not Windows. We just make it really easy to take COM components and make them into web services, and take web services and instantiate them as COM components. The key to this is that we have tools to take a type lib, convert it to a service description, stick that stuff over the wire into a proxy engine. The proxy engine will pull it up, generate a programmable proxy, and that includes a section that will actually serialize SOAP back onto the wire. The SOAP goes back and talks to an ASP that we've created. Now, at a much lower level, or not too much of a lower level, how this thing is actually going to work. It's a wizard. So you start out, let's say you start out with a COM component. You don't have to. You can have any arbitrary application. You can start with nothing. We just make it very easy to take a type lib and convert it to a contract. You're showing that, yes?
I'm not showing the part about converting a type library, but that's
okay.
Because the wizard wasn't ready to show that when I was...
Okay, so you're not getting that.
That'll be in what they gave later in the month. We're just
right.
not showing that today.
Once that contract is there, we make it very easy to instantiate the contract as a proxy. This is using ROPE, the Remote Object Proxy Engine, SOAP on a rope, haha. And then program against it. I've heard them all, by the way. If you think you have any good SOAP puns, just bring them to me. I'll figure out a product that we can build around them. It enables you to program against this thing as though it were a local COM object. In addition, it includes a SOAP serializer so that we can put SOAP back on the wire, and at the same time that you generated the contract, we will generate a SOAP listener. And that SOAP listener will, when you direct your when you build your application, the proxy will send the SOAP through to the listener, which then activates the application on the back end. Now, this is the Windows-centric version of the world. This is what the Web Services SDK from Microsoft does, and you'd kind of expect us to make it really easy to get Windows to work well in this environment. Now, the cool thing about this is, again, it's all abstractions. So if the server stuff were all in Unix, it would still work. You would have to write the SDL yourself, or create a tool that would expose the SDL, or buy a tool. You would probably have to create your own listener application or use one like the one from Developmentor. But our proxy could still take that SDL and instantiate it as a COM component. The reverse is also true. If you had a COM component that you wanted to expose as a web service, it's trivial to expose it as the web service and to build the listener, and then somebody programming in Java or Corba, a Corba environment, could similarly treat the service as though it were a native Java bean or a Corba component. So I've kind of gone over a bunch of the features that are in the toolkit, just to drill it home. On the client, there's the Remote Object Proxy Engine, instantiates the components, and there's the transfer engine that can send things back, and the SOAP serializer. On the server, we have our SDL extractor. It's the term sometimes used as a dehydrator. It takes a watery object and boils it down or something, I don't know. And we enable you to generate both ISAPIs and ASPs on the server side. And with that, I'll actually let you see code. Over to Michael.
Thanks, John. This is screen, which screen is it? 4? Okay. So as John mentioned, without respect to how the service is implemented, the one thing that you're focusing on when you create a web service is what's the object model. So that's the first thing that I think about. I don't, maybe I'm going to use COM, or I'm going to use ASP, or maybe I'm a Unix guy. It doesn't matter at that point how it's implemented, because the first thing you're thinking about is what's my object model. So I'm going to go through 3 steps in this demo today. And the whole purpose of this demo is to give you an idea of what does a web service look like when it's built, and in particular, how do you use the Web Services SDK for Microsoft to do that. So the first step is we're going to build a web service. Then the second step is we're going to put together a really quick VB app just to test the service and make sure that it's working. And hopefully that will be successful, and we'll be able to move to the third step, which is to actually do something interesting with that service by integrating it into a rich application.
So like I said, you're among the first people to actually see this.
I actually got it working last night right here. So that was kind of, I don't know, they probably heard me war whoop out in the hallway. So the first thing we're going to look at is the object model. We're going to build a translation service, a language translation service, very simple service. And this is an XML description of that object model. John referred to it as SDL, Service Description Language. So this is basically an XML IDL. We have an interface name, translate service. We've got a method called translate. It has 2 parameters. One is the message, it's type string that we're going to send into the service. And the other one is an integer indicating what we're going to translate. We're going from English to Portuguese or German to whatever. And then it returns a string, which is the translated message. So this piece right here, you'll notice, a URL. This is the location of the service. So in your description of your interface, you also include where on the web do I go to access it. Okay, so we've got an object model here that we kind of like. And our next step is to create the server files that will listen for the SOAP messages that are talking to that interface and do that work to do the translation. So I'm going to start up the Web Services SDK wizard, and this is the part that I'm not going to show where you can generate an SDL file from a COM object. I already showed you the SDL file. I wrote that by hand. What I'm going to do is ask the wizard to go out and get that XML file, translate.xml. That's this file that you're seeing right here. And I'm going to go on to the next step. And again, this is the part that's not done for if you're going to use an ISAPI listener. Down here, we've got 2 steps, 2 things we're going to generate. We're going to generate source code on the server. This first one, the static.a, in the back you can't see that, it's the bottom listing, static.asp listener file. So that's our generic SOAP listener. It's the same file that lives on every single web service implementation that uses our SDK anywhere. And it's actually a reference implementation if you care to look at it, and it's well commented, well written, in my opinion. But it's completely a black box. You can ignore it. The thing you care about is this file here, the interface file. This is a skeleton file that that has basically prototypes in ASP for the methods that you listed in your interface. So I'm going to tell it to generate those files back in the location of that XML file. And I'm going to come, now we see we have 3 files. So translate.xml, that's the service description. Listener.asp, that's the generic listener. That's the same on every server that implements a service using our SDK. And then there's this interfaces.asp file. And let's go ahead and send that to my editor. So you see it's just a prototype, and I need to fill it in. I need to write the code for this. Wrote this last night, and I'm just going to go grab it. So this is some code. I'm going to steal it here, and I'm going to copy it into that other window. I'm sorry this font is so small. I forgot that I should have made this larger. Didn't think about that. Okay, so this code, first of all, it's going to parse the I language variable to determine what's our translation. And then we're going to create one of the rope objects. This isn't the proxy object. This is a object that's used by the proxy object to actually go out onto the web and grab the interface descriptions and send SOAP messages and stuff. So wire transfer, this just posts HTTP posts to the web and encapsulates the response. So the next 2 lines of code are going to set some HTTP headers. And then, this is the important line right here, we're going to go out to AltaVista. And we're going to use their Babelfish page. And we're going to scrape the results of that page in this code right here. So now, obviously, if you're going to be launching a business doing translation as a web service, AltaVista's, they're probably not going to appreciate you doing this. But for the purposes of a demo that you write in 5 minutes before a talk, this is kind of helpful. So we've got this done. So make sure I didn't screw anything up. Okay, we're going to save this. Okay, now I've got the implementation of this thing done. I've got the description of the interface. I've got the generic listener that dispatches SOAP requests into the implementation in interfaces.asp. So the next step is I'm going to copy these 3 files onto a live tap back in Redmond. And while that goes, I'm going to go ahead and so this service is live on the internet as soon as it finishes copying. Before the copy, it's just sitting here on my laptop. So let's fire up VB and go on to the second step. We're going to throw together a quick VB app to make sure the service works. I hope it works. Okay. So let's have a text box where we're going to type our message that we want to translate, and one that we're going to receive the translated response, and we'll put a button on here. And let's write the code behind the button. First, we're going to go add a reference to the rope library so we can instantiate the proxy object. So let's go down to the R's and select the type library for rope. Okay, now I can dim X as new. Okay, now I have a dumb proxy engine. It doesn't know anything about services yet. It doesn't know anything about the translate service, that's for sure. So the first thing we're going to do is load the schema for the translation service, and we're going to specify it as a URL. And what was that URL? Did it finish copying? Yeah, good. Increase the size of the font? Okay. 131, 107, 916. Okay, so now I'm going to tell rope where to go get that this description of our service. 131, 106, 91, was it 7? Mm-hmm. 91.6, was that it? Michael. And translate the XML. Let me just double check that. 91.6, Michael. Translate XML. Okay. So now we know where the. So let's set the contents of text2 to be equal to. Now we're going to call our service. Now, so when that second line of code is executed, the load schema code, rope is going to access the wire transfer object that I showed you when I was implementing the service. It's going to go out to this live tap, and it's going to grab that translate file, load it, parse it, and dynamically generate a dispatch table. So now on this third line of code, I can, using late binding, make a call to the translate method on that translate service interface. And I'm going to, I can't remember we're going to go to German, so English to German, 1. Okay, and we're going to pass in the contents of the first text box, and then we'll set, okay.
Does it work with other languages?
Yeah, it works with everything that Babelfish will translate.
Hey, okay, audience poll time. Who wants a language other than German?
I had 3 years of German in high school, but I forgot it all. I could probably read it, though.
Well, it doesn't seem like there's overwhelming demand for the feature.
So we're going to say hello to the world, and we're going to send that off to our service, and we're going to get hello Welt, hopefully, back from Babelfish. All right. So it's working. Okay, since that worked, we can go to the third step. So the third step is, does anybody in the audience know what a COM add-in is for Office, for Microsoft Office? And I'm going to add a feature to Outlook. How many people in the audience? I used to write a lot for MSDN, and we used to put our email addresses at the bottom of the articles and encourage people to write. And I would get mail from all over the world, and people thought I knew Italian and German, and I had the hardest time. I'd have to find someone that knew the language. So I thought of that when I was thinking about what I wanted to show. And then I looked up on MSDN and I figured out how to do it. Actually, I shouldn't take credit for this. One of my guys did, Chris Dangler. If he sees this, he'll kill me if I take credit for his code. So what he did was he figured out how to write a COM add-in, and that allows you, I'm not going to go into the details of COM add-ins except to tell you what they do. So it allows you to write a COM object and to implement some functionality behind buttons and combo boxes and stuff that can go on to an extended toolbar that can be added to Outlook or Word or Excel or any of the Office applications. And so what you see here, should I increase the font size on this too? So what you see here, first of all, is the translate string routine. Now, if you looked at the other one, this looks similar to the VB code. We're going to instantiate an instance of the proxy engine, and we're going to load the schema, and then we're going to translate it, and we're going to set the return value, and there's some other code in here. This is another reason you're going to write your own translate service. The Babelfish thing kind of chokes on some characters, and actually these aren't all of them either, as I was finding out last night. But anyway, so, and then there's a piece of code here. This is called by Outlook when a mail message is sent. So I'm going to look at there's a combo box that I added in my custom COM add-in stuff. It's going to look at the language you want. It's going to get a pointer to a reference to the item, the mail message, and then I'm going to translate the body and translate the subject. And that's pretty much, the rest of this code is specific to doing a COM add-in. So I already built this last night, and you can see it's right here. So, and I can specify English to German, and I'll write a message to myself. Touchpads. I really like this service. Actually, it's a feature. It's a feature. So I'll send that. And hopefully, it's taking a little bit longer because as is going out and translating the subject line, and it's translating the, you can see it worked. All right. Now we're going to get it back. And it says, Ich mag wirklich diese Eigenschaften der Ausschrift. And if anybody in the audience knows how to make the on-action property work on command bar buttons, I'd appreciate some email on that. I've got some posts out in some news groups, and I wanted to be able to translate this back to English, but it couldn't get to work. But that's the demo. Thanks, John.
Cool. So I'm afraid that you had to listen to me talk for an awful long time before you got to the really cool stuff. You have to listen to me talk for a little while longer, but at this point, I think you've seen an example of what this stuff can do. And the concept of using anything that's out on the web as a component, I mean, just imagine what it would have been like if we had actually asked Michael's team to write a translation service. I mean, the Babelfish guys have been working on this for years, and we were able to basically completely destroy their business model. But that's...
No, they're going to create a service.
They are going to create a service. The benefits in some ways speak for themselves. I mean, productivity goes through the roof when you're able to do stuff like this. So all of a sudden you get a whole new class of build versus buy decisions. Not only that, you get a whole new type of business models. When you think about it, you know, if what you're going to be doing is offering some kind of a website or some piece of software, there are only so many avenues that you have to get that in front of people. The guys in the web business call it the problem about eyeballs. And it turns into this little tautology. There's only room in the top 50 Mediametrics websites for 50 websites. But that doesn't mean that there isn't room for a vastly increased number of services that sit behind them. So you can imagine eBay all of a sudden deciding that it's going to componentize its entire architecture and outsource chunks of it and just maintain the part that's its actual business value. I'm not going to dwell on this too long. You've seen what it implies from a high level. You have providers. They're basically going to be providing content-type services. And you're going to have aggregators. Today, the model is basically the provider sends it directly to the consumer, usually through HTML or some of the really cool services out there, like DoubleClick, for example. That's a nice example of a web service, not using SOAP, but it uses today's technologies. If you look at, there's this very neat little desktop application. Have you ever heard of, how many of you have heard of Are You Sure? I get this whenever I talk about it. It's this cool application, areyousure.com. It basically is a price comparison application. It sits, and when you're in an e-commerce site and you look, you click on a specific book, it's going to pick up that click event, grab it, figure out what the book is, grab its ISBN number, and then start shuffling through. It actually shows you the prices from comparative sites. And if it finds a lower site, it's going to say, I found a lower site, click here to buy it at this other place. Now that, of course, destroys the business models of all these other places. But it's actually a really cool application, and I use it all the time. There's that class of service. Underneath or around all this stuff are these mega services that are providing services that you never see. In order to get them all to work together, they have to agree on some kind of a common set of protocols and a common architecture. Otherwise, your time to market is vastly reduced. And we think that the SOAP SDL type route is probably the best way. It's the most promising way to do it right now. Business models. So if you look at business models on the web, there are two sides to them. There's the business-to-business side, where I consume some service and I pay you for it on the back end. And there's the business-to-consumer side, which is where the consumer actually has to pay for it in some way. So I figured out that there are about 5 basic models. And there's the second one that could be split into 2, but I'm not going to split hairs, and I didn't have time to update my slides when this lightning bolt of inspiration struck. Free doesn't sound like much of a business model, but You can imagine an auto insurance company, and we're actually working with someone who's thinking of doing this, providing this service, and in fact, I think has provided it. They just haven't announced yet, and I don't want to pre-announce. But they provide free access to an auto quote service. Just the same way you go into their website and you can tell them the make, model, year, and miles on your car, they can give you an insurance bid. Well, they can offer that as a service. Why is that interesting? Well, if you're at something like CarPoint or any of the other auto sites, and what you want to be is a one-stop shopping center, what you want to be able to do is when somebody says, I want to buy this 95 Mazda Miata with 60,000 miles on it, you can not only say, well, here are all the bids that you'll get, here are all the cars in stock in our used car knowledge base, but also here's how much it's going to cost to insure that. Do you want to buy insurance at the same time you buy your car? Now, that's free to the consumer. It's free to the aggregator, the CarPoint in this case. And the insurance company is going to make money off of selling those insurance policies, the same way they do today. Another model that I think is actually going to be very promising is a subscription-based model or a usage-based model. So either I pay you per time or I pay you per use to use your service. So if I am people do this today to get like real-time stock quotes. You have to pay for that as a service. Well, you can imagine this is actually the model that Passport uses. They say basically you buy a year subscription for N dollars and you can access our service, and here's how to get in. Now, there are some challenges with this model, particularly with the usage-based model. There are technical hurdles to be overcome because it's very difficult to track user accesses to a service. The guys who've been doing advertisements know this very well. It's hard to follow click-throughs, hard to know how many page views have translated into eyeballs on the ad and stuff like that. So there's a real call here for some of this, the authentication infrastructure, the non-repudiation infrastructure, and then just logging. And not only that, billing. I mean, how many people in the country, in the world, know how to send out bills for microtransactions? Well, when you actually get right down to it, there's one, and it's the phone company. They're pretty much the only people who are really good at aggregating, you were on for 3 minutes using this service, so I'm going to charge you 35 cents. You're laughing. Why are you laughing?
Everybody hates the phone company.
They're the phone company. They don't care. They don't have to. Somebody's going to build this infrastructure, though. It may or may not be the phone company. I had a very interesting meeting with a Bell company a while back, and their problem was that their entire billing system was written in COBOL, running on a mainframe, and they had lost the source code. So maybe the phone company isn't going to be who's offering this, unless you happen to know a way to reverse engineer compiled COBOL running on MVS. Take a cut. I'm sure they figured the problem out by now, and they're, I'm sure, loyal Microsoft customers.
We still support COBOL.
We do actually support COBOL. Take a cut. This is the model that all of the Visa and MasterCard use. So for every transaction that goes through, they basically say, I get a %. So if you've ever gone to pay for a taxi with a credit card and you wonder why they bulk, and they'll bulk more with certain cards than other cards, it's because the credit card is actually taking money out of their pocket. This is, in theory, this could be a B2C model, but I primarily see this as a B2B model, where basically the service that's offering rare books, and they have thousands of rare books, they have their own storefront, but they don't get much traffic. So let's say they cut a deal with an Amazon.com or a BarnesandNoble.com to offer their wares through the larger site. Well, I can imagine the case that Amazon is going to take a cut of each transaction for aggregating that service in. I can also imagine that if Amazon really needed rare books, that it could be the other way around, and the rare book company might take a cut of some, of Amazon's transactions on something else. That one's a little harder to work out. Advertising. This is, when I read all of the reports, this is where everybody is thinking all the great money is going to be. I hear numbers like, oh, it's a $19 billion a year internet advertising. And I'm like, I just don't see it, you know? I see overvalued .coms advertising on other overvalued .coms. And when the venture capital dries up, they're out of business. That advertising revenue stream is going to dry up. I also see that the primary advertisers on the internet today are companies that don't necessarily have a huge vested interest in keeping that revenue stream. A lot of them have been big companies that have been driving toward television advertising. Microsoft is one of them. I don't see a huge model for advertising. Having actually come out of an industry which was entirely garnered its revenue off of advertising, I was in the trade magazines, I can tell you that it's very labor intensive, and it's actually a fairly, often a very low margin business. It's not a great business to be in. However, I imagine, and I have heard this from customers who've tried to build things, that there has to be a way so that when the aggregator aggregates the services, that they can have an agreement with these services. So say my used bookseller says, I'll give you my service for free, but you have to pass an advertisement through to your end user. Well, it gets messy in a bunch of ways because it's XML, right? I can strip the advertisement out. Again, you're going to need to be able to encrypt that packet and ensure through non-repudiation that the advertisement actually went all the way through to the end user. It's a very complicated problem. The last model I see is what I call the software model. This is the one-time fee model. You know, I buy your software and I get the service for free. I buy your cable box and I get a year of cable. I get cable for free. Wouldn't that be nice? Again, I think that kind of defeats the purpose of a lot of what we've been talking about as far as the flexibility that services offer. You should be able to turn them on and turn them off as you wish. You shouldn't be necessarily forced into a one-time fee. That said, it's a very simple business model to create and enforce. And until a lot of the infrastructure is in place to actually make the other business models work, you're probably going to see that happen. So just like components are sold today as components, and you pay once and then you keep using them, that's probably going to keep happening for quite a while. Obviously, any of these, not any, but these can be mixed and matched in different ways. I'm not going to dwell too much on that. So we have a whole bunch of companies that have actually stepped forward and are building infrastructure around SOAP and web services. It's actually interesting because here in this group, you don't see a whole lot of, and there are a lot more, you don't see a whole lot of companies who you think of as traditionally being, you know, Microsoft, I'll do whatever you say companies. We have a bunch of companies that come out of the Corba space, like RogueWave and Iona and ObjectSpace. Now, these guys, their business is interop. And in fact, when we made our first announcement of SOAP and sent it to the IETF, I actually got a call from one of these companies, I won't tell you who, from their CTO guy, who basically said, well, we've been working on the same thing, and we basically believe that IOP is fundamentally broken for doing anything over the web. It's just never going to get there. So what would it take to get you to let us support SOAP? And to which my reaction was, cool, you're done. Also in this space are a whole bunch of open source guys. Again, you don't normally see open source guys leaping to the fore and saying, Microsoft, yeah. But it's interesting because, you know, Secret Labs AB, aka Pythonware, Scriptix, these guys build something called BizConnect, and it's kind of like BizTalk. Digital Creations, they make the ZOAP application server. And actually, there's a funny story to tell there. When I was way back before we announced SOAP, it took a detour and was called XOAP for the XML Object Access Protocol, because, you know, if you sprinkle XML on anything, it's good. Well, I got a call from one of the co-authors, Dave Weiner at Userland Software, who very politely told me that there was this cool company out there called Zope. And if you pronounce X-O-A-P the way you'd pronounce it, Zope, you probably have a little problem of confusing things. And so I said, Dave, you're probably right. So I called the digital creations guys, and I said, we have this thing called SOAP. And I'm willing to change the name if you'll support it. And his response was unprintable. But when I explained to him what it was, he said, that's cool, we'll support it anyway. We wound up changing the name back to SOAP because internally inside Microsoft, we confused virtually everyone who'd ever worked on the process because marketing made this decision to change the name, and all the guys who were actually architecting it, they had hard-coded in all sorts of SOAP stuff. So it was just easier to change the name back. In addition to the infrastructure support, we have, there are a bunch more of these. Obviously, Microsoft is going to support this. How many of you went to VBITS or heard about the VBITS announces? So Steve Ballmer got up on stage, and he started talking about the next version of VB and how VB was going to be supporting web services. And that's VB7. And in fact, all of Visual Studio is going to be building against this model. We're not leaving the current model behind, but we're adding this capability to consume web services as components. So the VB7 demo basically integrated together a stock ticker and some other personalization information in VB. And it's actually kind of cool because you can create a web service just in the current syntax by saying dim web public. And then the entire rest of the thing that you write is exposed as a web service. The syntax is going to change. Similarly, you get a nice user interface. We're able to take a bunch of the existing web services and represent them as with a visual control. So you can drag that control onto your screen, and we know what to do with it. It's kind of cool. Well, at the same time that we've been building this support into our products, we've had an evangelism team from DRG, Developer Relations Group, working with a bunch of potential web services. And they are signed on to deliver 200 live web services by June. So far, we have about half that. And they range the gamut from all sorts of financial services, stock quotes, 401k information, stock portfolio management information, your bank information. We have companies that are just coming forward, and they see this as a really cool way of adding value. You can imagine a future version of Money. Money 2000, if you haven't played with it, is kind of, it's a proto-consumer of web services. It integrates the IE shell into the application, and it seamlessly goes between your local store and these remote Money Central, actually, in this case, services for your stock quotes and live updates and things like that. But you can easily imagine a situation where you're not actually browsing to HTML doing that, but you're consuming the service, and you can surface it to the end user using the rich Windows UI. So you can have transparent overlaid windows and stuff like that. You can take advantage of a lot of the cool features that you get by programming against local UI, except you're consuming a remote service. I already told you about the insurance guys. There is a jobs site. They are basically building a support for a little ticker that you can build in the bottom of your application. You give it your job title, it'll tell you how much you could be making now. There's a whole bunch of opportunities here for travel stuff, too. Obviously, sites like Expedia have, Expedia or Travelocity, any of these sites have a huge number of things that they're going against on the back end. Well, you can imagine that if you want live updates on the time when a plane is actually going to land, sometimes the actual data that you're getting is stale. I don't know how many of you have ever been stuck in an airport, and I was stuck in Dulles a couple of weeks ago because I was trying to fly to Boston, and there was a snowstorm in Boston. And it was like they canceled all the flights to Boston but one, the 9:35, and I was like, I'll just hang around because I'm on that flight. I knew they really had canceled it, because that's what you do, right? Boston's under 18 inches of snow. They're not really going to try to land a plane on it. Anyway, it turned out that there is actually although the United folks hadn't gotten the update, there was a site that I bumbled into. It's actually a Unix site that offered the ability to get live FAA updates on where planes were and how overloaded or underloaded airports were. And I was able to see that Boston was shut down and that my plane hadn't even left the ground at like 9 o'clock from Boston to come down and pick me up. So I pretty much knew that it was canceled. Now these guys are going to be offering themselves as a web service. And you can imagine a next generation travel site that is able to give you tons of information about flights that have been canceled, or what airports you really should be going through or shouldn't be going through. Integrate that with some of the online buying capabilities, some of the, say, the not Department of Defense, the guys who do the Department of not Interior, Department, not the Travel Department. There's somebody in the U.S. government that actually has like
State Department.
That's them. Madeleine Albright. They actually keep information on like countries and is it safe to go to this country, what you should expect when you go to this country. Well, we actually built a demo that was able to screen scrape that HTML, aggregate it together with mapping information from Expedia, aggregate that together with information about flights and flight prices, and we were actually able to build an entire single-point travel service that was able to tell you, if you say, I want to go to Mozambique, it's able to tell you, here are the flights that go in there, here's what the weather's like this time of year, because we pulled down a weather service. Here's what the exchange rate is, because we sucked that out of an exchange rate site. Here are the warnings about going there. And also to say, this time of the year, you're going to need mosquito netting. And link us back to an e-commerce site where we were actually able to buy mosquito netting. And that was actually all fairly live. We only had to hard code one part of it because we were using a version of Expedia that hadn't been released yet. So what do we want you to do? Well, you can pull down the SOAP spec and look at it. I would say that's a good place to start. Understand how it works, understand this model of programming. But beyond that, think about how to provide your software as a service, and think about how to consume these services and how things can work for you. Look at the specifications we're going to be releasing in the next couple of weeks. Download a copy of my now disappeared colleague's Web Services SDK when we make it available.
On MSDN.
On MSDN. So that you can actually consume things and expose things and get a feel for how this works. We think there's a huge benefit to developers, just in terms of productivity gains.
It would be a lot easier to do that demo that you guys did.
Yes, it would be a lot easier without having to screen scrape HTML, and it would work from version to version. Anyway, and the last thing is, if you just want to get a feel for what's going on, go to the Developmentor site. They have a very active SOAP mailing list, and there's a lot of good thinking going on there by people outside of Microsoft who are kind of understand this. Questions?